Okay, let's get started. I'll post the agenda here if you want to add anything, or I'll share my screen. Welcome everyone, big group today. Okay, I'm going to start from the top. I thought Max was going to be here, so I want to say congratulations on being our newest contributor. Not here yet though, but still congratulations to him. Or our newest approver, I mean. And in case you haven't seen it, I just wanted to warn everyone that we found this expect 100 continue Go router issue. Of course, you know, Go 120. We knew there must be something wrong that was going to come up, and it did come up. So we have a fix out. Make sure to get on the fix, or else your access logs will have many status code 100s when they shouldn't. And if you're using certain clients don't like having multiple expect 100 continues and might error on you. So I'm happy to talk more about that if anyone runs into this, or you can read the doc. Let's see, Jeff added something. He's not here today, but he submitted this PR. This comes out of a conversation that we've been having about making sure that we think deeply about changes that happen to GoRouter's routing algorithm, and that probably for those changes, we want configuration flags when we make them, at least initially. So that way, in case anything goes wrong, it'll be easy to turn off the change. And so he's provided a change to the PR template here, just so that when people are submitting PRs, we're more likely to catch these issues and just update it. You know, this thing references Bosch Lite. Maybe you all use Bosch Lite still. We don't use it a lot anymore. But it'd be great to have a review from some others if you have thoughts on it. Now I'll turn it over to Stefan.
Yeah, hi, thanks. I just wanted to raise awareness for this proposal, which was brought up by SAP, and also wanted to take the opportunity to introduce our colleagues from SAP who are responsible for logging service, who have raised the issue. And yeah, maybe there are open questions from anybody, or maybe I give opportunity to Niklas and Benny to maybe explain a little bit shortly the background.
Yeah, maybe I can do that. Can you hear me?
And maybe
you can also see me.
Steps how to bring to.
Yeah. So basically,
yeah, go ahead,
Niklas and I are. Okay, the latency is a bit high on my side. So basically, Niklas and I are working in a development team that is also developing an external log management system, and we wanted to improve our ingestion performance because we're also ingesting logs and also metrics from Cloud Foundry over the HTTP syslog channel so far. So we've been waiting for syslog TLS to arrive to basically switch to TCP routing internally, but we failed to ever check whether we can really do layer 4 routing internally in our external log management system. And we figured out it comes with a lot of problems on our side. Still, we would like to have improved ingestion performance. This is why basically Niklas came up with the idea of implementing some kind of batching approach. And this was already discussed with Stefan and his team internally. And basically what developed out of it is doing a combination of both providing a writer that supports HTTP2 and also supports batching for external log management systems. We are aware that this is an issue regarding the protocol specification, but we don't have a specification for HTTP anyway. So we thought about proposing this solution to improve the ingestion performance, because we have pretty good experience with using FluentBit as a log shipper, which by default batches JSON logs and simply sends them to us, and we can reach ingestion numbers of like 25K logs per second with that easily. But if we use HTTP or even syslog TLS, the limit seems to be, at least for syslog TLS, 4K logs per second, which is great for sure. But we are pretty sure that we will need a little bit more on top. Also, there are bunch of other stuff that could be added on top here. For example, we thought about later after the meeting that if you ever want to use an external log management system as a Cloud Foundry landscape operator, you will most likely be concerned about egress costs for using this external log management system as well. And this is where HTTP 2 and even HTTP 1 plays nicely with compression. Because logs look mostly the same, especially on the metadata level. So you can save a lot of costs here by simply using batches instead of sending messages one by one. So this is basically, we get something for a log management system, and also you get something as a community for saving a little bit of costs, because maybe for some use cases, this might be significant. I hope that was not too much. Or does anyone have some questions regarding this? Because I didn't follow up on the actual issue, because I wanted to discuss it in this round first before writing some more information in the issue description or in the issue comments.
I think I have some context that I'd like to add at some point. I'll probably just leave it as a comment in the doc. I just became aware of this as a GitHub issue today. But I'll try and add some context and some thoughts, if that helps.
Awesome, great. Yeah, for sure. Yeah. Actually, internally, we want to do a first spike and simply try it out. Because adding batching on top, at least non-configurable batching at first, would be pretty simple. So we can do some playing around with the whole mechanism, and then check the actual performance and whether this results in any benefit for us. And then we will simply continue with the implementation and also with the communication over the issue, if that's fine for the community.
Carson, I think I saw you unmute. Did you have a comment?
I had a previous question. Maybe I can ask that now, if that's cool. But what you were suggesting, Benny, before I started to ask this question, all sounds good. Stefan Lay had mentioned that HTTP 2 could fill the gap for batching. I was wondering if that, if y'all looked into that, since there wasn't responses to that on the GitHub issue.
Yeah, we could simply start with that because we want to do both in combination if it's possible, but maybe we can start with simply just HTTP 2, do some performance testing on our side, see whether the results are convincing, and if not, we can simply throw batching on top. Yeah, because of the aforementioned advantages.
So if I understand correctly, batching brings benefit even with HTTP 2, because then you can still on top compress the content.
Yes,
somehow.
exactly.
Yeah.
And
It's also,
I just checked the, sorry, go ahead, Nicholas.
yeah, so it might also be an issue if you pipe very many requests to very narrow proxies. If you do HTTP 2, you also probably have some open connections. And if you get too many open connections, it's probably better to have a batching solution and not a like connection-based approach, because then you can get congestion even if your throughput is not that high already.
Yeah.
And just so I understand, you think HTTP 2 will give you benefits because you're going to be using the streaming, like that part of H2?
Will improve our performance for sure, I think. So we didn't try, but it's pretty easy to guess that it will improve, because currently it's ping pong between the services, and that's utterly slow. And if you can at least do multiples and then get one ARC back, it's faster for sure, but batching will probably beat it by 10x still, if it's done correctly. So that's why we want to try it out, to give correct numbers here, and that you can also decide on more of a factual base, and not like we think it will be faster, so we can actually say, okay, we tested it, that's what we got. What do you think of it?
Yeah, that'll be great to have data and numbers. I know you are always good about testing and sharing those. I remember working with the networking policies and stuff. So
We
thank
will
you for
also
doing that.
follow up with the comments in the actual issue on GitHub as well. We just managed to find time yet to do this, but I'm going to take care of that together with Niklas.
Perfect. Thank
I have
you.
a short question about the batching part. If we if we do batchings, do we want to do only one way, and then we say that we're highly opinionated in the batching part, and we say that this is the best way that we've tested and it works, or we do something like I don't know, some kind of plugin mechanism or some kind of callbacks that we enable the operators to add some custom code which will do the batching before the requests are sent over the wire practically. So just showing as an implementation idea.
I mean, as a first spearheading, we will not do that for sure, but afterwards for the correct implementation and later on down the road, I can think something like that might be sensible. Yeah, sure. If we do the implementation of the whole thing. I mean, we will do if we need to, but yeah.
Yeah, we will support you in any way possible, so to speak, because we find it's an interesting improvement to the whole thing. And from our experience so far, we always say that the syslog is the protocol to go and to be used when you have high log load, but also see that some people are selecting HTTP as an option because it's an easier implementation on the log consumer side. It would be interesting to see how the whole thing evolves.
Okay, sounds like people are generally in favor of the idea. There might be some specific questions to answer, but sounds great. I look forward to seeing the data from your prototype. Thank you for coming and talking about this.
I have a short, like a technical question. Do we need to create an RFC for the issue, or we can continue working and documenting things on the GitHub issue?
This seems low level enough to the logging and metrics subsystem that I think an issue on this repo is fine personally.
Okay.
I agree. I think RFCs are good when we're coordinating between working groups. But good question.
Yeah, thank you.
Okay, I'm gonna turn it over for the spicy one from Dominic. I don't know where this is going, but I'm interested.
Okay. All right. A little short on time now. Oh, you're sharing? You have to give up share.
Would you like to share? Here, I'll stop.
Yeah, I have some slides. Whoops, share.
Not only slides.
The goddamn system sharing thing needs to be enabled. Whoops. Oh, I have to quit and reopen. No.
Maybe while you get that set up, I think maybe Eric just has a quick item that he can cover.
Yeah, sure. This is a follow-up to Amelia's excellent CF presentation. But I think we're both curious to know fairly broadly if people are observing any problems in their CF environments that are related to kind of unoptimized traffic going across availability zones. So, I mean, we've had kind of like a few different customer requests on the VMware side that could be related to this, but we kind of want to know if there's broader problems around this. So this could be like, some examples could be like, are you seeing cases where you're seeing greater response times to app requests because like go router to app is going across availability zones and that latency hop is introducing a lot of additional time, or are you seeing a lot of just log volume from like the logging system components crossing across AZs? Although I think there's maybe some initial AZ awareness in there. So again, not expecting to get any necessarily synchronous responses here, but have a think let me or Amelia know if there's anything you've observed that you could attribute to that. We'd definitely like the information.
I have it on my list to send you a message, Eric. we'll do that.
Oh, awesome. Thanks,
later
Patrick.
tomorrow,
I talked to Florian because I chatted with him at CF Day, and he said he'd relay that to you.
Perfect. Thank you, Eric. And I look forward to
Oh man,
seeing what you
this is
send, Patrick.
what is this?
Over
Can
to
see me
you,
now?
Dominic.
Hear me? All right. Okay. Sorry to cut you off, Eric. I'm totally short on time now. Okay. Harald the Herald. Who is that guy? This is what this is about. 502 bad gateway. Every time I see that error code, I die a little inside. I hate it. So we should do everything and anything to avoid it, because customers also, I think, don't like it that much. So just a little recap. We didn't have route integrity for the longest time, and it was very simple. You just did HTTP to your instance. If that instance failed, you had an easy way of telling that it actually didn't respond. So you just had this very low-level error message, dial error, connection refused, or whatever it is. Downside was no encryption, and you could potentially route to the wrong app on the retry. So we all know that. So we added Envoy to the picture as our intermediate proxy that took care of all of this of these problems. So we solved the encryption problem and we solved the misrouting problem, but maybe inadvertently added a new problem. I call it the retry problem, because Envoy basically never sleeps. It always accepts your TCP and TLS connections, no matter what, even if this backend app is down. And it just closes the connection to GoRouter, which leaves GoRouter in a state where it has no idea if anything of this HTTP request had actually made it to the backend app or not. So that's very unfortunate, because it basically renders all of those retries unusable now. We sort of worked around it, trying to fix it on the GoRouter side by adding idempotency checks and HTTPtrace. Idempotency basically means a request that can be repeated, so get, head options and so forth. So if we find an end of file error that we got from Envoy and we had a GET request, we just say, okay, that's a repeatable request. We see an error, but we just figured we could retry because it's harmless. Not so much for post and put requests. For these, we added very recently HTTPtrace to the picture, which is a little library that allows you to track the state of HTTP requests inside GoRouter. And it would call callbacks, like functions that we provide whenever a certain state was hit. So for example, if GoRouter had written the headers of the HTTP request, it would call us back, and we knew, okay, we made the assumption, at least, that the app already got our headers. So if it failed, then we couldn't retry the request. The problem is it's still very unreliable. The main issue is that the Go standard library calls these callbacks not just when the headers have actually been sent, but whenever it actually wrote them to its buffer, like the outgoing buffer. So this callback basically gets called like always, even though the no bit of this request has ever made it to the backend. So that's, before we take a look at the solution, let's dive a little into this end of file error. So the basic problem that we face is Envoy takes your TCP connection. You then send the server name indication in the TLS client hello. Envoy then tries to look up the backend for this server. In this case, it's just one backend because there's only one app per each Envoy. It tries to connect, gets a reset because the app is down. Then it makes a mistake, in our opinion. because it finishes the TLS handshake, leaving Go router in a state where it thinks, okay, I have a TCP connection. I have made a successful TLS connection. I'm actually talking to the correct application because the certificate is correct. I'm now going to send HTTP because why not, right? And right along the same millisecond, Envoy then proceeds and sends a FIN closing the connection because it has no backend. Go router doesn't get this memo, basically. At the same time, in the same millisecond, sends out the post request, which is then, of course, reset by Envoy again. In this case, Go router has no idea why this connection failed, and it just can't make any distinction or decision if it can retry. Okay, so the problem statement is basically this: Envoy always finishes the TLS handshake, even if there's no backend. This changes the client and puts it in a state where it has initiative. So the client then thinks, okay, it's my turn now. I'm about to send HTTP now because I have a live collection. And that's not the case, of course. So if we wanted to make this more reliable, we have to basically drop this TLS handshake. We have to make it fail early enough so that the Go router would not be in a state to proceed, because it would be waiting for the TLS handshake to finish first. Envoy can't help us here because it always will behave like it does now. It's basically it's just doing what it's supposed to do. It's a very specific requirement that we have. Okay, who's going to help us here? We just figured we could do it ourselves at this point because Envoy won't budge. They won't change their code. Why not replace an Envoy with a Harald? So they are basically doing the same thing, but not quite the same. Hence, we call him Harald the Herald. Why? Because why not? It's a very simple and plain layer 4 proxy, but it knows how to behave. So the difference is, unlike Envoy, Harald will abort the TLS handshake if there is no backend available. It won't finish TLS unless it also knows there's a backend. That's basically it. That's the whole difference. One of the major differences, like in the size of these two, is that Envoy is huge. It has like a plethora of features, of which we use basically none, right? We use TLS termination, and we use forwarding and proxying of TCP connections. So why not just have a custom-made tailored solution that just does just that for us, instead of having this huge 200 megabyte Envoy that doesn't do what we need. So the main difference, going back to this diagram between Harald and Envoy, is that if Harald has gotten your TLS client hello and tried to make the backend connection, it then immediately aborts the TCP connection without sending the TLS server hello. In this case, Go router is in a different state and will not think that it already sent HTTP. It won't start sending HTTP. That's the major difference, and it allows us to safely make the decision to retry or not to retry. I have a little demo, just looking at the time. Just 4 minutes, that should be enough. It's very simple. I have a little Cloud Foundry deployment here. I have a bunch of apps deployed. I deployed an app that's called Don't Speak. It's very simple. It has 10 instances, out of which 9 don't respond. So only one instance will always talk to you. The other 9 will just, they are not listening at all. So you will get a connection refused to them. When I call this app in the classical way, using a post request with Envoy in between, I get a 502. And I have basically a 10% chance of these 10 instances, only one is going to respond. Oh, no, now I hit it. But like 90% of these requests will fail. Now, when I switch to Harald, so the guy I just introduced to you, these requests will always work. It's the same code, the same backend app. What you see when you do a CF logs on this app, hopefully, is that you see all of those nice retries. So here you see, for example, connection refused, and then the next guy is the correct one. So it will retry until it's finished and found the working instance, and the other 9 it will just ignore. So it depends on like the random selection of this endpoint. Sometimes it's fast, sometimes it's a little slower, but you can see it here. All of these connection refused come in a row until it finally hits the correct one and returns a successful response. So that's it for the demo. I have one more slide, I think. Just for the outlook, Harald is very much proof of concept at this point. It's very recent, I'd say. Kudos to Max, by the way. He wrote like 99% of the code. It's very early, but it works, as we've just seen. And we feel that in general, if there's no strong argument for Envoy, why not replace it with a more fitting solution that actually works for us? And we still have some work to do, like we didn't do performance tests or whatever. And we still, the way we integrate into Cloud Foundry is hacky a little bit. We still keep Envoy, but we shut it down and replace Harald. And Harald would just step into Envoy's shoes, basically. The question from us is like, is this interesting to you? Are there any strong arguments pro Envoy? Are we missing something? Like, is it strategic to use it or whatever? So this is our question. We don't know. We just have the tech to like improve, but we don't know how to proceed from here. So that's why I'm here. Thanks.
Yeah, that's very exciting. Carson's clapping. I appreciate the very detailed presentation about exactly what's going wrong. That really helped. Can you please make sure to share these slides, or I'm sure you've opened something to share more broadly.
Sure.
I think my strongest argument pro Envoy, like what I'm thinking in my mind, is I know we've wanted to use other features of Envoy. We're like, wouldn't it be great if we could do, and then there's like a handful of things, but we've never actually got it working.
Mm-hmm.
And as far as I know, we don't have any current features that we want, that we plan to use Envoy for. For example, you know, like something like at one point we thought we might do like fully TLS, container to container networking, and we would have all C2C networking traffic exit via one Envoy and then enter via the other Envoy.
I see, yeah.
But we've never done it. Or you know, we couldn't get it working. And it's not on the feature right now. I guess the other thing,
even previously, yeah, when we'd been looking more seriously at Istio, then we were, you know, looking at reusing that Envoy. But again, that seems like it's not really feasible at this point.
Yeah, that's true. Oh, go ahead, continue.
Yeah, I do recall, like, one of the things that was attractive about Envoy when we first introduced it was the relatively low memory footprint that we had. So that might just be something to validate about any other proxy that might replace it for this job, is that we could keep it within a similar envelope just to account for the overhead on all the Diego cells.
Yeah, we found that it's remarkably large, to be honest. I think I can recall some number from Max. He did test it, and it was like 200 megabytes or whatever. So it's fairly large for like the small like purpose that it should fulfill. But of course, it has lots of features, so those features have to go somewhere, right?
Just to be clear, those 200 megabytes, is that disk space or is that memory?
I have to call back on Max, I don't know. But I think he mentioned memory.
Okay, because yeah, we had some benchmarking of that. Again, when we first introduced it, it's possible that Envoy has gotten more bloated over time, although that was one of its original selling features, is that
It was
you know,
nimble,
yeah. It would have a low memory footprint because of all the optimization they've done in the C++ code base. Yeah, and I know that like that will grow over time with the number of connections that it's maintaining. But yeah, I mean, I recall at least at a kind of idle state, we had it benchmarked around, I think, between 16 and 32 megabytes. And we had some estimate of the linear scaling factor. It's in some Diego notes somewhere, I believe.
Your memory is amazing, Eric. Yeah, very interesting.
Should we like open RFC for that, or because it's touching not just routing, right? We need to also make changes in Diego, basically, executor.
Yeah, I think so. I think this is a big enough architectural change that people will have thoughts and comments. I think one question I have is, would this work on Windows? Because currently Windows is using its own non-Envoy thing.
Okay.
I think it's using Nginx, maybe that's in front or something. I'm not sure exactly.
Oh,
I think
technically
so.
it's just a Go program, so it should work. I haven't tried it.
Yeah, that might actually simplify things.
Yeah, that could be nice. Carson?
One thing that comes to mind is that maybe this opens up some possibilities for the HTTP protocols we use as well. I'm thinking back to when we implemented HTTP2 as an option for apps, and some limitation of Envoy that we never quite figured out prevented us from being able to magically select the protocol for the apps. I think one of the proposed solutions was like magical health checker running in the background that like pings apps to determine what protocols it could use and sets the protocol automatically. And Envoy had some weird thing where it would always accept like an H2 request, meaning we couldn't successfully like determine what protocols an app could respond upon. Perhaps with some kind of custom solution, maybe it opens up a road where we don't need to specify what protocol exactly an app can use, and under the hood we can introduce magic to do that. Possibly a bad idea, but it's more options, which is cool.
Yeah, it's unfortunate right now that you have to specify H2 and then the Envoy is set up with H2 and its Alpin right ahead of time. It would be nice if you just knew your app. Oh, well, your app works with H2. Oh, it starts doing H2. Yeah, cool. Dominico, look out for the RFC. Please post it in these slides. They're great when you do. And I'm sure there will be more questions coming your way, but it's exciting.
Okay, then. Thanks.
Thank you. Okay, I'm looking at our agenda and we're out of items. So thank you all for another great working group. If it keeps being this long, maybe I'll consider extending it to an hour so we won't go over and we don't have to rush Dominique. Perfect. I'll see you all next month.
See you next time.
Thanks. See ya.
See you. Bye.
See you in a month. Thanks. Bye.